All right, so in this video, we're gonna go over how to calculate the variance and the standard deviation of a set of numerical data, okay? So feel free to pause the video and read through this. It's really not the gist of this video. I'm gonna talk about the calculation part more. But variance is just a measure of the spread of data, okay, of data points. The variable, that's the most important thing from this, is the variables we're gonna use. So S squared for variance, and this is the lowercase sigma symbol, so sigma squared. Now the difference between those two is which type of variance we're talking about. Okay, so S squared is the sample variance. Okay, if you're working with a sample of an entire population, you're going to use S. If you're using the entire population, you're going to use sigma. Okay, so S squared for sample variance, sigma squared for population variance. Okay. Standard deviation is a more precise measure of the spread of data. Okay. And it's going to be the square root of the variance, okay? So we're going to use S for sample standard deviation, okay? And we're going to use sigma for population standard deviation, okay? So I'm giving you the formulas here. So the sample variance, this is the formula for the sample variance, so S squared, okay? It's going to be the sum of each individual observation in the data set subtracted by the mean, okay? We're gonna find these deviations from the mean, okay? And we're gonna square those deviations, okay? And then we're gonna add all those deviations together, okay? And we're gonna get the sum of those deviations from the mean to the second power, okay? And then we're gonna divide by the number of observations minus 1, okay? Once we get that value, that's the sample variance, okay? The sample standard deviation is just going to be the square root of the sample variance. Okay, so I'm going to walk you through this. So if this notation is a little bit new for you, I'm going to walk you through it step by step. Okay. Now notice here we're dividing by n minus 1 to find the variance. Okay, and we're not just dividing by n. The reason we're doing that, okay, in most statistical sets, you're only dealing with a sample of the population. In many cases, it's impossible or extremely difficult to get data on every member of a population, okay? If you're dealing with the whole population, you're going to divide by n. But if you're dealing with a sample of the population, you're going to divide by n minus 1, okay? And what using n minus 1 does is it corrects by making the variance and the standard deviation both a little bit bigger, okay? So we have to realize we're working with a sample, so we need to make those variance and standard deviation numbers a little larger. So we divide by a smaller number. Okay, so let's get into the meat of this here. We've got some data here. Person's metabolic rate is the rate at which the body consumes energy. It's important in studies of weight gain, dieting, and exercise. Okay, we've got 7 data points here. It's a very small set because we're making a video here. It's important to note that the units are in calories burned per 24 hours. Okay, and we're going to use these 7 values. So the first thing we want to do is find the mean of this data set. Okay. I'm not going to go through that calculation. You should know how to find the mean. Okay, we've got 7 observations, and the mean is going to be 1,600 calories per 24 hours. Okay, that's exact. Remember, X bar stands for mean. So if you were to average these 7 values, you get exactly 1,600 calories per 24 hours. Okay. Now, the next thing we want to do, and this comes from the formula here. The first thing we want to do is what's in parentheses. Think order of operations. We're going to subtract the mean from each of the individual observations in the data set, okay? So I'm going to subtract 1792 from 1600, and I get 192. I'm going to subtract 1666 minus 1600. That gives me 66. 1362 minus 1600 gives me negative 238, and so on. So I'm going to have 7 different deviations from the mean, okay? Notice the numbers that are bigger than the mean are positive. Okay, the numbers that are smaller than the mean have a negative deviation from the mean, okay? Now, the reason we don't use these values to help us understand deviation from the mean is if you were to combine these 7 values, you're going to get 0, which doesn't do us any good from an analytical standpoint, okay? What's going to help us is when we square all these, okay? And that's the thing we're going to do next. Again, think order of operations from our formula here. We've done the parentheses part. We want to square each of those individually. Okay, so when I square 192, I get 36,864. When I square 66, I get 4356. When I square negative 238, I get 56,644, and so on. So I'm going to square the other values here in my data set, okay? So now, from my formula, I've done the parentheses part, I've done the exponent part. So what comes next is the summation here, this uppercase sigma. I'm going to add all of these values together, okay? So next thing I want to do, I'm going to add the sum, or excuse me, I'm going to add all these squares of the deviations. So when I do that, I get a really large number, 214,870, okay? So again, look at my formula. Now I've done that part that's highlighted there, okay? So what I want to do now is divide that by n minus 1. Remember, n was equal to 7, okay? So I want to divide by 6, and that's going to give me the variance, the sample variance, okay? So the sample variance in this case is 35,811.67, okay? It's a meaningful number, but it's less meaningful than the standard deviation I'm about to find, okay? The larger this number is, the more the values in our data set are spread out. The lower this number is, the closer together the values are in my data set, okay? If the variance is 0, that means all the values are exactly the same, okay? But again, the larger that value, the more spread out we are. So this tells me our data points are pretty spread out, especially for just having 7 observations, okay? So to find the standard deviation now, I'm just going to take the square root of that sample variance, okay? So the standard deviation here is going to be plus or minus, because with the square root you can have a positive root or a negative root. So plus or minus 189.24. And notice the units here on the standard deviation are the same as the units in our data set, okay? I didn't put units on variance. You don't need to have the units on the variance, but standard deviation does need to have units, okay? So sample variance is 35,811.67, and this tells me that the standard deviation is 189.24 calories per hour. And again, that measures the spread of the values in the data set relative to the mean, okay? All right, now, let's move on down. If we want to find the population variance and the population standard deviation, I'm using the exact same numbers that I just found, but I'm going to divide by n this time instead of n minus 1, okay? So I'm going to take the sum of the squares of the deviations that I found earlier, 2,014,870, and this time I'm going to divide by 7 instead of by 6, okay? So it's going to make my variance a little bit smaller, okay? So we divide by n, and our sigma squared, which is population variance, is quite a bit smaller, 30,695.71, okay? To find the population standard deviation, I'm going to take the square root of that value, okay? And that gives me plus or minus 175.20 calories per 24 hours. So it came down, when we were thinking about this in terms of the population, by about 14 calories per 24 hours, okay? So that's how you use those formulas. The notation you just got to get used to. Understanding if you're dealing with sample or population is important, and how that affects what you divide by, n or n minus 1, okay?